So hi, I'm Paula E, and this is a program 2 from Lab 31C. So I'm going to briefly explain about how this coding is working. So for the first one is the data segment. So we have initialized five string with message instruction, input, result, display event, and message display all in a byte size. And for the total event, total all, and also hello variable, this one is array. We've initialized it in dword size, but we didn't give it any value yet. So for this one, hello dword 6 is an array that to store 6 dword integers. So for the bottom part is all of the coding. So later on, I will explain it line by line. So first of all, we try to review it first. Okay. To review it, it shows that 1 succeed and 0 fail. So I will directly start it and explain it with step 1. So to have a better viewing, I will make it a dual window. And here's the memory, watch one, orders, and also register. Okay. So I would like to see the hello address. Okay, this is the hello address. Okay, so let us try to run it first. So let's try to run it. So first of all, the first instruction is we need to write the instruction line. So first, we load the address of instruction message into the EDX, which means that we put the address of the message instruction into EDX. As you can see now, EDX have load in already. Then we call the restring function, then it will write out. And after that, we call CRLF function, which means that we skip a line. So next, we move 6 into the ECX, which means that we set the loop counter to 6 because the ECX register is controlling the loop. So next, we load the address of the hello array into the ESI. Okay, so for the next part, as you see, ESI here is good in the radio, in the address here. Okay, so the next step, we need to prompt user to enter 6 input, and this is the input loop. So it's like starting of the input loop. Okay, so first of all, we load the message input address into EDS and we write it out. And then next we call the read decimal function. So we need to read the input from the user. So let's try 20. Okay, after insert the input, so the 20 will store in the EAX. 20 is in decimal, but in EAX it will directly convert to the hexadecimal. So next we run it, and then we move the EAX into the ESI, into the address, into the content. Yeah. So as you can see now, the array here for the first content is the 14. The EAX is moved inside, and then after that we move the next element in the array, which means that like we add 4 bytes in it. So just now it's pointing here, right? So we add 4 bytes. 1, 2, 3, 4, and now the address will be pointing at here. Pointing at here. And now after that, we loop the input because just now we have setting the ECX to 6, right? So now after in loop, we have become 5. So we have 5 more. So it will go back to the input loop. And then we're doing the same thing. We write out. We call read that function. So let us try 25. Okay, after 25, we store in the EAX and then we'll move into the array. As you can see now, we've moved into the array already 19 in hexadecimal. Okay, then we move to the next element 1, 2, 3, 4. And then now the address will be pointing at here. And then we loop again, the ECX will become 4 minus 1 already. And then we do the same thing. We're just doing the same thing. Okay, 30. And then we load it in already. We load it in inside the array. And then we're skipping 4, adding 4 bytes. So now 1, 2, 3, 4. Now it's at here already. The address pointing here. And then we loop again the input. Now ECX become 3. And then we're doing the same thing. 37. Okay, EAX, the EAX, and then we move the EAX inside the array. As you can see now, it's become 25 here. Okay. Then we move forward, move 4 byte. 1, 2, 3, 4, and now it's pointing at here. ESI is changed already. And then we loop again, the ECX become 2. And then doing the same thing. 40. Okay, EAX is storing the 40, which is the hexadecimal in 28. And then we move inside the array. It's now come to here. And then we move to the next 4 byte. 1, 2, 3, 4. Now it's pointing at here. And then we loop again. Now ECX has become 1, which means the last line. Okay. The last input, 43. And then we just move inside to the array, and then we add 4 more. Add 4 more, which means 1, 2, 3, 4 is pointing here already, the inside. And then just continue to execute it because the input now ECX has become 0, then it will not go back to the input loop, but it will continue to execute it the next line. So for the next line, we will set the ESI to the point to the start of the array, which means that we move the hello. We're pointing at here. We move the ESI pointing back at the first one. And then we move 3 into ECX. We set the loop to 3. After that, we reset the EAX. We make it become 0. So it will go to the next function, which is count even. So we will add all the array in even part, which means that we have 6 array, right? But the array will start from 0 to 5. So this function is to add on the even part. So this one is a 0, array 2, and also array 4. And for the second one is array 1. For the fourth one is the array 3. And the sixth one is the array 5. Okay, so we count the even first. The even, so we try to execute. we add the current even index element into EAX. So just now the content of ESI is 14, right? So we add into the EAX. Yeah, so you see here, EAX. And then we move to the next even index element. How is it possible? So we add 8 into ECSI. So just now it's here, right? Then we add 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's pointing at 1E right here, right now. So 1E is the address of this one, 13. Okay, so we continue to execute it. Then we loop the count even, loop it. Because just now ECX have 3, right? So it haven't become 0, so we need to loop again. Then we're doing the same thing at the current even to the EAX. So as you can see now, EAX have become 32, because just now we are adding the 1E with the 14. The 14 is the EAX just now, and then we're adding 1E inside. Then we move to the next even element, we skipping 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now it's pointing at 28 here. ESI is pointing at here. And then we loop the count, we loop the loop again, count even loop, and then ECX has become 1. This is the last loop. Then we add the current even, we add the 28 inside EAX. So now EAX has become 58. Okay, and then we move to the next even element. There's pointing here 1, 2, 3, 4, 5, 6, 7, 8. So now it's pointing here. But after we've executed the code, it will directly go to the next line because the ECX has become 0. There's no need to loop it again. After that, we move the EAX into the total even variable. Now, EAX have moved inside. So after that, we just same like just here, we reset the ESI to the point of the start of the array. So we reset it. Now it's pointing at here. As you can see, it's pointing at here, the ESI. And then we move 3 inside ECX, we set the loop to 3. And then we reset the EAX with 0. Now EAX has become 0. But it's some different. We add 4 inside the ESI, which means that just now we are pointing at here, right? We add 4 by 1, 2, 3, 4. So now it will start pointing at here, 19. The ESI now is pointing at 19 here. Okay. So now we're going to the next function, which is count or looping. It seems like the count even looping, but this one we'll just need to adding all the odd elements. This one 25, 37, and also 43. So let's try. So we add the element inside into the EAX 19, just like I say it's pointing here, right? ESI, so it will add 19 into EAX. And then we skip 8 element. 1, 2, 3, 4, 5, 6, 7, 8. Now it's pointing at 25. 25. ESI. And then we loop the counter again. We loop the loop again because ECX haven't become 0. Then we're doing the same thing, adding the current odd index element into EAX. EAX now become 3E. Then we skip 8 bytes, which means that so now it's pointing at 25, right? Now we're skipping 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8. So now it's pointing at 2B. The ESI is pointing at here. Okay, then we loop again. Now ECX has become 1. This is the last looping. Then we do it again. Add the content inside into the EAX. Now EAX has become 69. Then we add 8 into ESI, move to the next 8. 1, 2, 3, 4, 5, 6, 7, 8. Now it's pointing at here. But because the looping is ECX has become 0, then we will not loop again. We will directly go to the next instruction. We move the EAX into the odd. As you can see now, the EAX. So now we move the EAX into the total odd. As you can see, EAX is having the value 69. We move into the total odd variable. And for the last one, last few steps, we need to write the result line. So we skip a line first, and then we move the address of message result into the EDX. And then we just write the string out. Yes, after write the string out, we need to write the result sum of hello event. So as you can see, we also move the message display event address into the EDX. And then we write it out. And then we move the total event into the EAX. Total event 5A into the EAX. And then we write it out. We write it out in decimal. So the 90 will come out. And then we skip a line. For the last one, we need to write the result sum of the hello odd. So the same, we move the address of message display odd into the EDX. After moving it, we write it out. And then we move the total odd inside the EAX. We move the total odd inside the EAX. After moving it, and we write it out. We call the write decimal function, and then the 105, we write it out. And then just skip a line, and then that's how the coding done. Okay, that's all from the program 2. Thank you.